platform for building web and mobile apps very quickly. So I'll go through some of the arc of why we settled on this architecture and do a little bit of a demo if there's time. So let's talk about modern apps. We're in the midst of a really big shift in the kind of applications that people are writing, the kind of applications that users are demanding now. And the top line story is obviously going from the browser to mobile. So the fact that we all have these supercomputers in our pockets now has completely changed the expectations of what it's like to interoperate with a great application today, right? We're talking about cross-platform apps that run in the phone. We're talking about everything from graphics, acceleration, touch sensors, GPS, all the device hardware that allows us to build this new kind of experience. And then, of course, a lot of that is also true in the browser. The browser itself has turned into an operating system, top to bottom, right? And we can get accelerated 3D graphics, sound, network connectivity. We can open sockets. All the things you would expect of an OS are now elements of the browser itself. But there's a deeper aspect to that goes beyond just how do I get my app on the phone or how do I get my app into this rich browser experience. And it really comes down to a shift from what I call a thin client architecture that the web was all about to a thick client architecture, which is what we have when we use a telephone to run our software or when we use a web browser. So as an example of what we're talking about, on the left we've got your classic website, right? Bread and butter, HTTP, HTML that we've been using for the last 10, 15 years. And on the right, we have a couple examples of a much more modern experience, the kind of thing that people have grown to expect. So we've got Facebook and we've got Uber. So these things are so different, right? I mean, for example, at Uber, we don't have a web page. We don't have pages at all, in a sense. The application is live updating, right? So we can see when we're ready to ask for a ride where all these cars are. And the drivers can see where all of the passengers might be. And as we're starting to learn, Uber Inc. can see all of us. And so that wouldn't make any sense if we built it as a website, right? What am I going to do? Hit refresh every couple minutes to see if there's somebody nearby? It's an inherently different kind of experience, a different kind of application. Or Facebook, right, where I've got a dialog box that pops up, so a modal with state when I want to invite friends to an event. I've got type ahead search in that box. It's a much more fluid experience. It's also collaborative, right? So in both of those examples, I'm using the application alongside other people. And one way or another, I can see the results of what they're doing, and they can see the results of what I'm doing. Google Docs is another good example of this. Whereas on the left, if I'm reading NewYorkTimes.com or Yahoo, I'm doing my own thing. And for the most part, what I'm doing doesn't relate a whole lot to what anyone else is doing. And as I mentioned, we even have dialog boxes, modals, right? We've got almost like a desktop-like app experience. What's interesting is, 10 or 20 years ago, the enterprise had the best software, right? We would go to work and we'd use these amazing pieces of software that were built for Windows or for Solaris or our workstations, and then we go home and the PC software we had was kind of like, yeah, it's okay. But look at what I've got up on the screen, right? The best stuff today is not in the enterprise anymore. It's in consumer, and it's because Facebook and Google, Uber, Asana, Quora, Twitter, all of these companies, these key business metrics that they care about are directly related to the quality of the application experience they can provide for people. So the tables have turned, and it's the enterprise now that has to catch up, and there's an opportunity to take advantage of the lessons we've learned in the architecture that they've developed to be able to build great mobile-first enterprise apps. And that's what I want to talk about. So underlying all those differences are some key technology differences. So we've gone, as I said, from this thin client. The browser was really stupid, right? It got a HTML document and it rendered it. That's it. To a thick client. Most of the code in a modern application is actually on the device that's running, right? And that's what lets us build these very lightweight, node-based RPC endpoints on the server because a lot of the logic is moved. We've gone from presentation on the wire, so an actual document, a specification for what the thing should look like, to data on the wire, where we have JSON APIs, right, and structured data that a program can work with. We've gone, and this is a big one, this is going to really upend our world. The web was all about stateless request response, right? So HTTP, it's amazing what you can do with a stateless request response protocol, but here we are. You make a request to the server, you get back an answer, and that's the end of the conversation, right? So everything we build is based on that paradigm. The architecture of our servers, the way that we write our apps, that is not what's happening with a Facebook or an Uber. We have to hold open a WebSocket. We've got to have a way for the server to push information to the client. We don't have a refresh button. So our only option, if we want to show the cars moving around on the screen, or we want to show friends as someone RSVPs to an event or likes a photo, our only option is to push data in real time down to the client. And so that's a totally different way of doing business. So here's the problem. For the most part, we're trying to build this modern experience on top of the old stuff. So we start with the thing that we're comfortable with, and which frankly is well built. So we've got our back end, we've got maybe it's Rails, maybe it's Node, maybe it's Java with Spring, could be anything, right? A stateless request response back end, and what we're trying to do essentially is retrofit it with something really different so that we can have this desktop-like experience in the browser. So Angular, of course, goes into this retrofit layer. Before Angular, we would use things like jQuery or Backbone to help us do this, right? The mean stack is a retrofit. It's taking a request response system, Node and Express, and then adding on top of it a bunch of infrastructure to try to fake this pub-sub architecture, this real-time live updating architecture. You can do it for sure, but the problem is it takes a while. It's a discipline that requires expertise. Maybe in business terms, expensive, slow. It actually doesn't help you a whole lot with mobile in any event. You're still stuck with a whole separate problem for building your iOS and your Android stories. And all of this ties back to this mismatch, this architectural divide between the 15 years of the web that we had and the coming era of this new approach. So here's the new thing. And if we look inside Facebook or Twitter or Quora or Asana or any of the companies that have invested heavily in this kind of an experience, this is what you find, a completely different stack that isn't tied to the old HTTP-based request response era. So there's all kinds of stuff here. So we've got, just to pick, for example, one of these boxes, right, a client-side data store. So it turns out, let's just puzzle this out for a second. If I'm going to build an app that has state that's running on a client, there's a lengthy network connection between that client and the server where the real data is stored. And inevitably what this leads to is I've got to cache some of that data on the client. I can't build a responsive user interface if I don't do that. Everybody builds one of these things. One way or another, and I see some heads nodding, you're probably building a client-side database of some form with some API. And it's ridiculous because none of these boxes, up until I get to the very top, are actually about my app. They're about this architectural underlying problem. And that's true for what's my protocol on the wire between the client and the server. I guess we'll use a WebSocket, but I have to invent messages that sit on top of that. And it's different for my app than anyone else's app, right? It's 2014, and I can't plug a real-time API into another real-time API. You can't plug Facebook's real-time API into your app the way that you can plug a REST API into your app, because nobody agrees. All kinds of problems around how do I update my screen in real time based on the way that that data is changing. Am I going to glue that to something like Angular? Am I going to write callbacks and do something a la the style of a Backbone app, right? Choices I have to make as a developer. And it's kind of like in the 70s, we had databases, right? If you were building an application for your VMS system, you had a database. But the way you had that database is you called the database expert, and he came into your office, and he like wrote a bunch of B trees, because he went to database school, and he knew how to make B trees. And query planners were people. And it worked, but God help you if next month you wanted to sort your customer list by like order size instead of like date. The guy had to come back and make a new B tree. So Oracle comes along and says, look, we've built this portable database engine in C that you can just drop into your app. And it turns out it's the same thing in all of your apps, and now you can just write in this very nice declarative SQL language. Completely changes the way that we build business software. So the same thing is happening here. We can standardize most of these elements that go into a modern stack and share that investment across all the different applications that people are building. And that's what I want to talk about a little bit. So all of these boxes have a standard way that we can settle on that allows us to build those things. And let's talk about a few of those things. And there's actually a term of art that I'm seeing floating around recently called cloud client. So that's what we're building here, a cloud client architecture, because of course we have part of our server is now run, or part of our logic rather, is running on servers in the cloud, and part of our logic is running on the client. And if we embrace the fact that our code runs in multiple places, and it's all live updating in real time, we can build a clean sheet design that's a lot more effective. So a couple ways we can look at this. I don't want to dwell too long on this. I'd actually rather play with it as a demo, but let's just talk about a few of the things that have to go into an architecture like this. And you might hear some of this and recognize some of what you've been building in an ad hoc way in your own apps. So, for example, in a live updating app, we almost certainly need a way to watch our server's database for changes, right? The root of a lot of what's changing on my screen is an actual fact in the database that changed. So in the case of Uber, for example, we probably do have a database somewhere of where all the cars are. And so I need an effective way to efficiently watch a database. It's very different, right? A traditional database, I do a query, I get back an answer, I'm done. That answer is stale, but I don't know that. So we need a different primitive where I can actually observe a query and get callbacks when something's different, when something's added to the result set, when a result set changes or the sort order changes. And it turns out we can do that in a fairly standard way. So Meteor comes with such a thing called live query, which lets you watch a database for changes. Another thing you almost certainly need, and I touched on this before, is a protocol for pushing those changes from the server to the client. And it's really important that this be standard because I want to interoperate across different applications. I also want some sense of security. I mean, this is really terrifying to think that we're going to start building apps this way. We have to, because this is how you deliver a great experience. But our whole approach to security, something that's come up multiple times today, is whatever the web developer decided that month when they built their protocol. That's nuts, right? We can't possibly reason about security across the organization or across the enterprise border if we're making these things up each time we go. So we need something standard, something equivalent to HTTP, but that's about pub/sub. I mentioned the database on the client. We've got to cache this data. I suggest we do it with a real database API because as the apps get more complex, we want to be able to do things like filtering and sorting and doing subselects from the data that I've cached. And so if you build something ad hoc, what you find typically is that works for a while and then you outgrow it. You want something more and more capable. And then once we're in the client, we need some facilities for seeing that that data has changed and drawing my screen or rerunning JavaScript functions accordingly. And so there are components for doing that as well. So that's sort of a functional walkthrough of some of what goes into a stack like this. But there's actually, I think, a more interesting take on it, which is about the philosophy behind it. And now I get into a little more specifics of how Meteor does it. So here's our thinking on Cloud Client. If you're going to build an app like this, you need a few things to do it well. First one is you've got to have full stack reactivity. Every element of your stack has to be written reactively, which is great news for JavaScript fans and for Node fans because JavaScript is such a good fit for an event-driven reactive architecture. Other languages aren't, right? But everything from the APIs we watch the database with to the APIs we cache data on the client to the way that we redraw our screen, all of that, rather than being imperative programming, should be done in a reactive, declarative way. And you'll see that when I go through a simple demo. The database ought to be everywhere because in computer science terms, we are writing a massively distributed app when we build one of these things, right? We've got some processes running in the cloud. We've got potentially millions of processes running on various clients. And they're heterogeneous clients. So some of them are web browsers, some of them are iPhones, some of them are Android devices, some of them may be IoT devices, right? And the networks between these things aren't perfect, and they're not fast. So we've got all the problems of a massively distributed system. How are we thinking about consistency? How are we thinking about security in a setting like that? So the programmer, if faced with the fact that their data is far away from their logic, is going to have a really tough time, and this is one of the reasons it takes so long to build these things well. We want to present an interface to the programmer where they don't see that problem, where the database APIs are the same no matter where their code is running. So you'll see that. The third thing is, and this term isomorphic, I think came out of an Airbnb talk that Spike Brem gave. So credit to him for the idea. But the idea is, if I can use the same code in all those different settings that I mentioned, there are massive efficiency gains for the development experience, right? So if I don't have to juggle between different APIs for how to access my database on the client and the server and the phone, if I don't have to write in JavaScript in one place and Objective-C in another place, I can have one team. I can have one investment in what we're learning. I don't have to bring in specialists for every platform I want to support. It's a huge difference in how quickly, especially at a larger organization where there are large teams, how quickly you can ship an app and how quickly you can iterate on it. I can move resources around between different elements of that. I don't have this sharp divide between my back-end team, my mobile team, my browser team that slow us all down. And the last one, and I don't know, there may be some differences of opinion here, but most people like writing synchronous code. So in particular, when we write business logic, and I'll show you a more detailed example of this in a second, I want to get away from the event-driven style where it's not as helpful. And if you're building a simple REST server, this isn't such a big deal, but once you start writing more complex logic, it really comes into play, and we'll see that in a second. So here's an example of isomorphic code. This is all pulled from different Meteor projects I had floating around, and everything you see on the screen runs in the browser, runs inside a phone, and runs in the cloud in my server environment. So for example, my database API, where I define a Mongo collection and then do an insert or an update against that, those things can run everywhere. So I can share my model code. We can actually, in fact, the second example is pretty cool because what we can do in a cloud client architecture is we can RPC to the server, which we all understand, that's where the real stuff happens. That's what the client is asking the server to do, and the server is going to make a security decision and either accept or reject the request. But we can also simulate the same thing on the client directly so that we don't have to wait for the server to update our screen. It's really, really handy. And to be able to do that simulation using the same code saves us a lot of work. So that's an example of what you're seeing here with these two methods. If I want to talk about URL routing and rendering, I want to be able to do that both on the client and the server. So of course the router can run in both locations. And same for network services, right? So it's kind of nuts that in Node we've got an API for doing HTTP GETs, and in the browser we've got an XHR API, which kind of does the same thing, but it doesn't work the same way at all. So it's very difficult to share code. In Meteor we can unify that so that you can type the same kind of HTTP GET, and that works whether we're doing it using cores on the client or whether we're doing it in the server as part of a server-to-server RPC. And here's an example of what I mean by callbacks. So classic bread and butter business logic, the kind of thing we all do in Rails in a controller that's super easy, where we need one request to the database, and then depending on what we get back, we do another thing that depends on the first thing, and then depending on what we get back, we do a third thing that depends on the second thing, is super hard to write when I've got to nest all that stuff as callbacks. And of course, there are different ways that people have approached structuring that code, but I think for the most part, what we see is a real desire to be able to do that in a really straightforward sequential way, and so we've tried to carefully architect the APIs to allow that, and you'll see that in the demo. So I thought maybe I'd just show some of this, if that's cool. They're excited about it. Let me just find my mouse. Let's see here. Okay. Is that big enough to read? Yeah? Okay, so I have a little app that I set up just earlier to save you a little bit of typing time. So Meteor comes with everything you need to build an app. So I've got that SDK installed on my laptop, and I'm now running Meteor against this code. And what we're going to build is a simple list of names and scores. So my app's running now in localhost, and let me just open up the two halves of this application. So, oh, I see. Perfect. Is that good? Okay. So the top half, I've got my basic HTML for this application. In fact, let me just open this up for you. So we've got a, we're going to call a partial template called leaderboard. This is using handlebars as templates. You can use Jade or a different style if you prefer, but I find handlebars very intuitive and easy to look at, so we'll do that here. And then the template's really readable, right? We've got a loop of some kind that we'll get into in a second over all the players. And inside that loop, we're just going to render a div, and we're going to pick out a couple of attributes for that player as we go. And then let's look at the JavaScript that powers that. And so welcome to Cloud Client. So this JavaScript runs both on the server and the client. So I'm going to declare a collection. I'll use Mongo for this demo. So I'm going to declare a collection called players that holds the list of players and their scores. And then I've had one piece of code here, which is the thing that connects my database with my template. And let me just get both of those on the screen so we can see that. So that loop over each players, well, we're going to feed that loop with this helper called players. And players is just going to return a database query. And if I'm a Mongo developer, this is very familiar. I haven't had to learn a new fake database for Meteor. This just says, give me all the documents in the players table, and we'll extend that query in just a little bit. So okay, my app's running. Let's load that up. I don't have anything in the database, so I just have an empty screen. And what I'd like to do is open up a Mongo Shell. So I'm connected directly to the backend database now that's backing this whole app. And I'm going to do an insert. So let's do, if I remember the syntax for the shell, db.players.insert. And I'll give it a name, Larry, and a score. Mongo's very nice because I don't need to design my schema in advance. So it's a good fit for building these kinds of apps. A score of 20, let's say. And that's really cool because when I do the insert on the server, all those parts of the stack we talked about just did their job. So the server is watching the collection. The protocol has pushed that into the browser. The browser has cached that information. In fact, let me bring up, just to show you that. Whoa. Oh, I'm in Safari. I didn't mean to do that at all. I don't even know how to use Safari's inspector. Can I put it back in the window? Who knows? Let's try a real browser. Okay. So, and forgive me, I forgot about that. So players.find.fetch, and here I am in the browser, but I can do a database query and I can get back my player. And I can run this a few more times. So let's add a couple more players, and you'll notice all the browsers are updating at the same time. So table stakes for a cloud client app, right? I've got to have this collaborative experience, and I don't want to spend my whole day building the plumbing to make that work. I just want to build the thing. So here we are with 3 players. I can do database queries, and I have the whole Mongo API. So I could do a find where score, let's say, is greater than or equal to 30. And if I did that right, I should get back the 2 players I expect, right? In fact, here's an example of where I might want to use that full API already. Probably makes sense to sort this list by score. So let's go back into my JavaScript, and I just have to make a change to my query that's feeding the template. I still want all the players, but I want to use the sort option for Mongo to sort by descending score. And if I did that right, we should get our scores sorting descending. So let me just add a couple more things here. Not everything when we talk about a reactive or a live updating app is about data that lives everywhere that everybody can see that's also in the server's database. We also have state in our application. So let's add just a little bit of that. What I want to do is have the ability to select one of these and then add to their score. So we'll do a couple of things. The first one is, let's add a selected helper. In fact, I think I may have this already, just to save a little bit of time. And so we're going to use session, which is a local state where I can save information that's only for the particular user. So I have a current player, which is going to be the ID of the document I'm looking at. And then let me add a event handler. So what I want to do is when I click on a player, I want to set that session to reflect the current player that's selected. And so I can click on a div that matches player, and that function is going to run, and I would do a session.set current player. So this is just a simple key value dictionary, but it's all reactive, and we'll see that in a second, to the ID of the document that I'm currently rendering. And if I did all this correctly, and it's always exciting with live coding, did I not balance something? There we go. So great. So as I click on a player, that particular player shows up. And of course, those don't affect each other's sessions. These are 2 separate users. And so now what I can do is let's add a button so that I can actually add to someone's score. So in my HTML, let's see, do I have a button? So I'm just going to add a simple button. You'll notice, by the way, that when I save my files, my screens update automatically. I'm not refreshing my browser. So even the development environment is reactive so that I can work very quickly. So I've got a button, and now what I need to do is wire that up. So here's the last piece of the puzzle for a cloud client app is an RPC. So in my JavaScript, let's define, and in Meteor we call these methods. Let's define a method called add to score. So this is like a REST endpoint that I can call from the client to ask it to do something. So add to score is a function that's going to take a player ID as an argument, and we'll do a database update based on that. So we'll do a players, and this is again just Mongo, standard Mongo stuff, players.update. We'll update that particular player ID, and the update is going to be Mongo's increment operator. So we'll increment their score by 5. So there's my method, and then I just need to call that method, and so let's add another event handler. So if I click on the button, we'll do a meteor.call, add to score, so that's the name of the method I'm calling, and the arguments are going to be the ID of the player I want to increment, and I can get that out of the session dictionary, so current player. So if all that's done right, we've got ourselves a collaborative app. And again, I didn't have to write any logic to watch the database for these changes. I didn't have to write anything to redraw my screen. When I call a method by clicking on a button on the right, it's going to send that RPC to the server. The server is going to run the method I wrote, which does the update of the field. The server is going to realize that there's another open tab in the world that's also subscribed to this collection, push that information into the browser, and then the client-side cache is going to trigger a redraw of the screen. And this stuff's pretty cool. So for example, if I go into Chrome, let's just take this particular player. So I'm just going to set, well, let me set one that I'm not selected. So Larry, wherever Larry is. Does this work? Okay, so I've made a local CSS change in my console over here. So Larry is red now in the background. Over here, I'm going to keep incrementing his score, and watch what happens. Right? So the way we update the screen has to be really intelligent, because it's recognizing that the score is different, so that has to patch the actual number. And that cursor, that query that drove the order of the list of what I'm rendering on the screen, that recognized that the order of the result changed, but we're not messing with any other part of the screen. So the system is actually forklifting the DOM nodes around in an efficient way, which means if I make this local change, or if I've also used, say, a jQuery plugin that's making an unrelated effect on the screen, those things can all coexist. And I show you that mostly just to point out the usual path when we build apps like this is we do a little bit of this stuff ad hoc. It's not that hard to imagine building a couple callbacks that would update my screen when a score changed, right? But the problem is, as the app gets more complex, these kinds of things come up more and more often, and you discover you're building more and more special case code to be able to deal with that very quickly. And so this is a much more flexible, kind of like how Oracle gives you a very clear and powerful query semantic. This stuff, this set of standard tools, gives you a nice, clean way of reasoning about the behavior of your app as you make it more and more complex. So let me just show you one last, I think I've got a few minutes, example of what I mean by this business logic and how valuable it is to be able to do synchronous code. So let's make a rule that we don't want the scores diverging too far. So we're not going to let you have anyone's score get to be more than, say, 20 above the next highest player. Let's see if I can just actually write that out in a reasonable way. So I'm gonna pretend I'm a Rails developer, right? I'm just gonna write it in the natural way you would do that. So we get this method call add to score, and so let's see. I'm gonna find my player, and then I'm gonna find the highest scoring player that isn't me, or I'll just find the highest scoring player. So that'd be find one, and the ID of the player cannot be player ID. Is that right? Yeah. And then I'm going to sort by descending score. So does that make sense? So I'm in my business logic, I'm going to pick out the player that I'm about to update the score of, and I'm going to pick out the highest scoring player that isn't that one. Again, normal Mongo stuff, right? And if you're not a Mongo fan, this is bread and butter Mongo stuff. You can imagine doing something similar in Redis or SQL if we use that. And so now I just want to say, well, if, how does this go? If me.score plus 20 is less than or equal to highest.score, then go ahead and do the update. But otherwise, don't. I'm going to reject the update. I'm not going to worry about error handling. We could throw an error and then catch that in the client and show a message. But just to illustrate the point. If me plus score, yes, of course. So if my score is no more than 20 higher than the other highest score, then go ahead and allow it. So let's see if that works. So we have DJ selected, so we'll add to the score, and score keeps going up, and we should stop at 95. And there we go, right? So because we can write really clean, straight line business logic that's synchronous in just a few lines of code, I can start to implement these kinds of complex rules. And yeah, enterprise software is more complicated than this rule, but it illustrates the point. And again, we're relying on all of that standard infrastructure to protect the data. So multiple users using this app, again, I can increment the score all I want, but the system is going to enforce that, and the screens that I'm looking at and people's experiences are going to be based on what the server decided to allow in the database. Yeah?
So if you go ahead and try to set parameters in the browser database, like the score,
Okay. So great question. So can I go into the browser's database and set the score to 150? In the interest of time, the answer is yes, but I'll show you what happened here. Okay. So let's find Larry. Oh, thank you. Players.find1, name is Larry. Excuse me? Oh, right. Okay, so players.update, Larry.id, and let's just set his score, something totally off the map, right? Something I'm not supposed to be able to do. So set the score to 2000. And it does work. Not so good. So what on earth is going on there? Well, it appears our app is insecure. Let's fix that. If only life were so simple, right? So this is our version of scaffolding in Rails. So in a bare Meteor project, we actually do allow you to make arbitrary database updates in the client, because that lets you play around with your interface very quickly. This is obviously not something you would ever do in production. Just like in Rails, you don't put scaffolding into production, but sometimes you used to use it just to get things off the ground quickly. So now that I've removed that, we won't be able to do this. So if I set the score to 3000, oh, access is denied. So the only updates that are permitted are the method calls that we've defined, and so the method calls still work, but I no longer have the ability to just set anything arbitrary in the console. Yeah. How chatty? Yeah, that's a great question. So the question is, talk about performance on the wire, right? Are we really talking about a lot of traffic on the wire? There's a lot of elements to the performance question. The story for the network is actually very good. So the server is only pushing the minimum number of updates that are required. So when I do one of these updates, we're actually getting a single JSON message over the WebSocket that says, set the score value of this particular document to 120. So that's already crunched down to the minimum set of updates. The other story here is I haven't shown you the lower level API for managing that conversation over the wire. So if you have a particular thing where you want to be more thoughtful about exactly what traffic you're sending, the APIs are there to talk at more the bare metal level, where you can say like exactly when you want to send that update, rather than relying on let's plumb observing a database query to pushing out the updates. You can actually be very explicit about exactly when you want those messages to go out in exactly what form.
We've got another question here.
Yep.
Could you update the example to show doing the queries in parallel?
Doing the queries in parallel.
Yeah, the two Mongo queries, the find and find one.
Oh, like for the secure logic here?
Yep.
In parallel. So you have a couple options. So we exposed the actual node driver. So I could do the bare node call. I don't want to do it in real time because I'm going to flub it and it's going to take me too long. The reason we typically don't do that, though, is that the concurrency model in Meteor is every client, so every open WebSocket, has a serial execution of its method calls. And that's for a very good reason, because it makes reasoning about the concurrency of a single user's request much, much easier. So we have the ability to say, if you want to pipeline methods from a single user, you can do that. You can tell there's actually an unblock, so I can call this dot unblock right here, and that says, go ahead and start running additional methods that are coming from the user at the same time. So that's sort of a related question to running two queries that are inside the same method call. Methods for multiple users are running in parallel, and the way we're doing all of this synchronization is using fibers. So the event loop is still, in fact, running multiple queries at the same time, waiting for them to complete and hit the event loop and then come back with the result. And the value of fibers is that it allows us to return values from the database query instead of having to nest callbacks where we're getting the result as a function call. That makes sense.
Using Mongo in your examples,
Yeah.
You also demonstrated observability on data changes in the DB. What if I use Oracle? Do I get something similar? Or
so we don't support Oracle today. There's some early support for, we have a version of this running on Postgres, for example. And I believe there's a community version that runs on MySQL. So here's what's interesting. There's two things that are interesting about supporting a database like Oracle. The first one is, so you're seeing me do, this is a Mongo query that runs in the client. So as part of the standard stack, we're actually giving you a in-memory JavaScript database that implements the Mongo query API. So for SQL, we have to give you a SQL database. Not as bad as it sounds, because we don't have to implement indexes and all the other things, right? The data is not that substantial, but you want to implement the API so that you can share your code, your business logic, your models, your validations, and so on. So that's one piece. The other piece of the story is that primitive of being able to watch a database for changes. So the question is, how do you do that efficiently? And that's different depending on the database engine. So Mongo, which does not include any inherent support for that, we do by watching the replication log. So I'm actually subscribed, I'm running on my laptop a Mongo cluster. The Meteor process is subscribed to the replication log, and it uses that as a hint for when data in the database is changed to be able to, because you saw when I did that insert, it's immediate, right? There's no polling, I'm not waiting. So that's the Mongo strategy. Redis, which we support, actually has a built-in notification system, so that one's pretty straightforward. In a SQL database, you're going to use triggers, right? So part of the story of interfacing with Oracle or Postgres is going to be, and I don't know how you do it in MySQL actually, but for a real database, you write a trigger so that the database knows when there's been a change that relates to one of the queries that you're watching, and then does, in Postgres, I know it's notify. I don't know what the equivalent facility is in Oracle. So those are basically the two pieces about database support in Cloud Client, is watching it efficiently and providing an isomorphic API in the client and on the phone so that you can share your logic.
All right, we have time for one more question. What? What? Just one more. Right over here.
Hi. Is it possible to use Meteor with other client-side framework, let's say AngularJS?
Yeah, you can. So the this is handlebar style templates,
Okay.
which uses a library we wrote called Blaze, which manages the DOM. So that cool thing where I can like change CSS properties and it keeps them sorted out.
Okay.
Instead of that, you can use Angular. That's a pretty popular stack. So you're using the data synchronization layer, you're using the isomorphic APIs, and then either because you have an existing investment in Angular or you know Angular and you want to use that, you can then use Angular to drive the screen.
Okay. So the database over the wire is still accessible to me if I was using Angular, right?
Yeah, and the Angular integration is pretty sweet because Angular, of course, doesn't have a story for where the data is coming from, right? It's like when your data changes, your screen updates, and you're like, well, where's the data, right? So it's nice because now you've got that data synchronization, you've got that cache, you can write those queries, and then you just tie in the dependency tracking in Angular with the invalidation stuff that we use as our rendezvous for reactive data, and you're off to the races.
Okay, cool, thanks.
Great, thank you very
So
much.
thank you.
Matt. Thank you, Matt.